Hello everyone. So welcome in the channel. So yesterday we were discussing the problem, the flattering of a linked list. That was a hard problem. We have discussed the brute force, and today we will be discussing about the optimal solution. So we will move step by step. So first of all, we should discuss the brute force. So for the brute force, we have simply put every element in an array and then sort them and then put back them in a node and making their own childs, and that's how we solve the problem. So flattering means we have given a node, we have given a linked list, and every element in linked list have a small sub-linked list, or we can say that the linked list which every node have their child, and their child may have another node or maybe their child. So that's the question of flattering of linked list. And so for the optimal solution, so we should firstly try to solve it for the two node linked list. So suppose we have a linked list that have two nodes 4 and 5, and the node 4 have their child and node 5 also have some their child. So we have to merge all the nodes that are given and their child and return the sorted list, but in the form of a single node and having their childs. So for this solution, uh, firstly I have taken the two pointers t1 and t2 and simply compared them, and whichever will be the small will come first and add on in our new linked list, and we move our that pointer to the next step of their child, and then compare t1 and t2, and whichever will be the small, that will be add on as a child of our current node in our new linked list. So that's how our loop will goes. And suppose if T1 all child are put in a new linked list, and T2 have remaining some child. So we will simply check if T1 is there or if T2 is there. We will add on remaining all the childs in a same order as they are in a sorted form. So that's how we will be able to solve for two nodes linked list, and using this concept we will be solving overall of our flattering of linked list question. So for this we will be using the concept of recursion and backtracking, and in this we will be trying to solve it for a very small base case. First of all, we will be reaching to the null, or first of all we will be reaching to our tail node, and after knowing that it's the tail node, we know that this is the last node. So the node and their child will be will be returned back as and to their next previous node, and after that the merge function will work and merge the last second node and their child along with the first node and their child. So that's how they will be merged together and will be returned as a sorted merge new head, and this thing continues until we reaches to our base case. And the base case is as if head is equals to null or head next equals to null, we have to return our head. So our merge function will traverse and will add our or simply say will merge the two list node by using the merge function that we have discussed previously. So by that function we will be able to merge two list, and after they will be merged together they will act as a single new list, and that list will be returned back with the previous node and their child, and again they will both will be compared, and that's how they will finally get combined, and we can return a new head and along with their all the childs in a sorted form. So that's how we will be able to solve this problem. So the complexity will be big O of n into big O of 2m, that is big O of 2nm, where we have n number of nodes, and every node have m number of height of their subchild linked list. So this is the time complexity. For the space complexity, we have used the stack space. So for that, our complexity will be big O of n. So that's how we will be able to solve this question easily. And now we will have remaining only 2 or 3 hard problems of linked list. We will be covering them as soon as possible, and until that I am revising my basic concept of stack and queue, and then I will meet you soon in our stack and queue playlist. Until that, stay tuned, stay happy.